Good day to you all. Today shall be talking about integration. Integration simply means anti-differentiation. And anti-differentiation means that what we use to bring differentiation back. For instance, if you say that if y is equal to x squared, we know that if you differentiate it, the y dx is equal to 2x. Now, we have deformed this this x squared to give us this 2x. How do we bring this 2x back to x squared? That is anti-differentiation, and that is what we call integration. And this is integral sign. So this is integral sign. So to now bring this 2x back to this, I will now write it like this. I will say integration of 2s ds, because this is ds. I will now say the integration of 2s ds, it will now be equal to s squared, because we know that it is differentiation of s squared that gives me 2s. So we can put plus c. C is a constant. We call it an integration constant, which must be there. So that means for us to talk about integration, we must know differentiation very well, because it is differentiation that leads to integration. For instance, here now, it is differentiation of s squared that leads to 2s. So definitely integration of 2s will lead to s squared. In that case, we consider the following tables. This is the table of standard integral. The first one, integration of polynomial. If I integrate s raised to power n, it will be s raised to power n plus 1 divided by n plus 1. So for instance, if I integrate s raised to power 2, that 2 is our n. So the answer will just be s raised to power 2 plus 1 over 2 plus 1. Then we must always put c. You can see that I'm putting c. If I integrate sin s, I will get minus cos s. We must memorize this. We must take note of this. We must memorize all these formulas. Also, if I integrate cos s, I will have sin s. If I integrate exponential s, I will have exponential s. If I integrate s squares, I will have tan s. If I integrate 1 over s, I will have ln s. We have done this under differentiation. And if I integrate 1 over square root of s, I will have 2 square root of x. So take note of this. Now, let us now consider examples. Let's integrate the following. The first one, we want to integrate s raised to power 5. So we should know that our answer is, I'll use the first formula there. This is the first formula. It will be s raised to power n. Integration will be s raised to power n plus 1 over n plus 1. So that means if you integrate s raised to power 5, it will be s raised to power 5 plus 1 over the same 5 plus 1. We say plus c, which simply means s raised to power 6 over 6 plus c. Now, you observe that when we integrate here, the power increases by 1. So that 5 becomes 6, then over 6 again. It will always increase by 1. Also, let's say we want to integrate s raised to power 3. So it will be s raised to power 3 plus 1 over 3 plus 1 plus c. This will be s raised to power 4 over 4 plus c. You can see that 3 is increased by 1 by the formula, because the formula says it is s raised to power n plus 1 over n plus 1. That n we are talking about here is 3. So you can see that 3 has become 4. So the power will increase by 1, then over the answer that it gives you, 4 over 4. So that means I can similarly say that if I integrate s raised to power 7, so 7 increased by 1, which is 8, then over 8, I will say our answer is equal to s raised to power 8 over 8 plus c. So which you must remember this. Unlike differentiation, if it is differentiation now, instead of this power to increase, it will decrease. If it is differentiation now, that I want to, let's say I want to differentiate s raised to power 7 now. Instead of this thing to increase, it will be this. I remember this 7 will come down. This power will now reduce by 1, making 6. So that will be 7 s raised to power 6. Now let's consider another example. Let's say we want to integrate x to the power minus 3 dx. If I integrate x to the power minus 3, it will be x to the power minus 3 plus 1 over minus 3 plus 1. That is, you just increase it by 1, then over that answer plus c. And that will be x to the power minus 2 over minus 2 plus c, because minus 3 plus 1 will give me minus 2. Minus 3 plus 1 will give me minus 2. So we can simplify. Finally, if I simplify this, I should have 1 over 2x squared plus c. So let's say I want to integrate another one. Let's now assume that we have 3x to the power 4 dx. And this will be 3. This 3 is constant. You can see that I've not been putting number there. But I put number now. 3 is constant. Then we say x to the power 4 plus 1 over 4 plus 1. It should be 3x to the power 5 over 5 plus c. So what we are saying is that the power will just increase by 1. If minus 3 increase by 1, it will become minus 2. Because you can see here that 4 increased by 1, we got 5. That means that 5 is more than 4 by 1. So if minus 3 increases by 1, it will give me minus 2, because minus 2 is more than minus 3 by 1. And if it is fraction, something like this, let's say we want to integrate x to the power half. If I want to integrate x to the power half, our answer will be x to the power half plus 1 over half plus 1 plus c. You can see we are just adding 1 to the power. So that is the basic. So if I simplify this one, I will have 3 over 2. If I simplify this, it's 3 over 2 as well. But that is not the answer. That's not all. This 3 over 2 is at the division. If you bring it up, it will become 2 over 3. Then x to the power 3 over 2 plus c. So that is the answer. But we can, this question is same thing as giving this. I may just give it like this, because x to the power half is same thing as square root of s. Because if you are giving square root of s, you only need to, or anything in this root, you only need to transform it to that power. Now let's consider example 2. Example 2. So let's integrate. Now let's generalize it. Let's assume that you have 2 x to the power 3 minus 4x squared plus 5s plus 1. And one more thing. If you integrate, let me put it here. If you integrate a constant, it will give you constant s plus c. Remember that if you differentiate constant, let's say 5, 6, 7, it will give you 0. But if it is integration, you just add x to it, because if I differentiate ks, I will have k. That means if I integrate 5, I'll get 5s. So when you are integrating a constant, just add s to the constant. Now, what we are now having, we want to integrate this. Let's do it one by one. 2 is constant. If I integrate s cubed, the power will increase by 1. That is 4 over 4 minus 4x. If I integrate x to the power 2, it will be 3 over 3 plus 5. Remember, this is x to the power 1. If I integrate it, I will have the 1 will increase by 1. That is 2 over, over 2 again, plus, this is constant. If I integrate 1, I'll just turn it to x. Then I'll put plus c. Don't forget that 2 here 1, 2 here 2. You can finish it. Let's assume that we have this as well. 4x to the power 4 minus 5x to the power 3 plus 6x squared plus minus 7 dx. If I integrate this thing now, 4 is constant. If I integrate s to the power 4, I will have 5 over 5 minus, if I integrate this, I will have 4, because this is 3, it will become 4 over 4. If I integrate this, I will have 3 over 3 minus, if I integrate 7, I will have 7x plus c. Don't forget that 3 here 1, 3 here 2. So that's our final answer. Now let's now consider this. Let's assume that you have x squared minus 5x plus 1 divided by x. I cannot integrate this thing directly because this one is in a straight form, but this one is not in a straight form. You have to express it in a straight form first. How do you express it in a straight form? Just say this divided by this divided by, because all of them are dividing x, so it will be x squared over x minus 5x over x plus 1 over x. So that is what we are going to have. So if I cancel it out, x squared over x will give me x minus x divided by x there will give me 5 plus 1 over x dx. Don't forget that this is x to the power 1. So if I integrate it, now I can now integrate it. It is now in straight line form. If I integrate x to the power 1, the 1 will increase by 1. That is 2 over 2. This one is constant. If I integrate it, I will just put x beside it. That is how to integrate a constant. Now, this one, 1 over x. If I integrate it, I will have ln x, which I gave you under table of integral. So, you still remember? And it's what we have done before. If you integrate 1 over x, you are going to have ln x plus c. So that means the answer here is plus ln x plus c. So that is the answer to this. Now, so for the trigger and all those things, let's assume that I want to integrate sin x plus 3 cos x minus 4 exponential x dx. You only need to recall, but I don't need to write out the table now, so it's just a straightforward question. If I integrate sin x, I should have minus cos x from the table. If I integrate sin x, I will have minus cos x. If I integrate cos x, I will have sin x. If I integrate exponential x, I'll still get exponential x back. So that the answer here is minus cos x plus, if I integrate this cos x, I will have sin x. So that will be plus 3 sin x minus 4. If I integrate exponential x, I will get back exponential x. So this is just 4 exponential x plus c. So that is our answer. And if I have something of this nature, d, okay, let's say e, I want to integrate 1 minus cos square x divided by cos square x. Don't forget that it's something of this nature. We cannot integrate it directly because it has something under it. We have to separate the division first. Now let's separate the division first. If I separate it, it will be 1 over cos square x minus, this will be cos square x over cos square x. So this is what we are going to have. Can you see? This is what we are going to have. So, and if we simplify further, we are going to have this. When we simplify further, so you now observe that why? Because cos squares cancel cos squares here is 1. So this is what we are going to have left. You are going to have this minus 1. So that is what we have here. Now if you take note of something, you should have done all this in secondary school. But if you have forgotten, let me remind you. So we should take note that 1 over cos, if you anytime we see 1 over cos, it simply means sec x. Also 1 over sec x simply means cos. Reciprocal of cos, we name it to be sec s. You can see that I can have reciprocal of cos here, but it is reciprocal of cos squared. So I will name it to be sec squared because reciprocal of cos is sec. In that case, reciprocal of cos square, we name it to be sec squared minus 1. Now, what are we now doing? This is what we want to integrate. So we have now written it in a straight line form. I will now recall what is integration of sec square s. Integration of sec square s is here. So this is integration of sec square s. It will give me tan x. Integration of sec square s gives me tan x. So our answer will be tan x minus, if I integrate 1, I will have x, then I'll say plus c. So what we are doing here is that we need to know the basic differentiation. When we know the basic differentiation, then we don't have any problem. Also, the knowledge of indices is very, very important when it comes to integration and difference. When it comes to calculus generally, we should know how to integrate and differentiate very well. Now, for instance, let's say we are asked to simplify this. S is super 3 minus 4s squared plus 1 dx divided by square root of x. We want to integrate this thing. You see, it's not in a straight line form. Our aim is first to express it in a straight line form. So this will give me s super 3 divided by square root of s minus, this will be 4s squared divided by square root of s. I'll first put this under all of them, 1 over square root of x dx. Now, since we have done this, the knowledge of integration will help us out here. So if you don't know the knowledge of integration, it will be very the knowledge of indices will help us out. If you don't know the knowledge of indices, all these things will be magic to you. Now, you know, from indices which we have done before, this square root simply means s raised to the power half square root of s minus 4s squared. This is s raised to the power half plus, let me leave this one because this one has standard integration which I have seen here. 1 over square root of s, it has value already. So I don't need to, if I can memorize that, I don't need to stress myself. The next one is s raised to the power, and if you don't want to memorize it, let's continue. Let's say this one too is s raised to the power half, all of them. By indices, we know that by indices, the division turns to subtraction of the powers when the bases are equal. So we can divide. When we divide, it will be 3 minus half. That is how to divide. This one too, and we divide this by this, it will just be 2 minus half plus, this will be s raised to the power minus half dx. Because there's nothing there, it is 0, it will just be 0 minus half. So from that place, if I simply, you can see that I have not integrated anything. I'm just simplifying using indices. So if I simplify this, 2 times 3 is 6. 6 minus 1 is 5. So here we have 5 over 2 minus 4s into, if I simplify it, 2 times 2 is 4. 4 minus 1, 3 over 2 plus s to the power minus half. So I finished simplifying it. So it's not in a straight form. I can now apply the idea of integration. How do you now integrate? I'll say 5 over 2 plus 1 over 5 over 2 plus 1 minus 4. If I integrate this one, I will have 3 over 2 plus 1 over 3 over 2 plus 1. And this one, it will give me minus half plus 1 over minus half plus 1. Which, if you simplify further, this one should give me s to the power 7 over 2 over 7 over 2. If I simplify this, minus 4, this will give me s to the power 5 over 2 divided by 5 over 2 plus s to the power, this one will give me half divided by half. I'll say plus c. You must always add c to your integration. And this one over here, if I bring it up, it will become 2 over 7. So this will be 2 over 7 s to the power 7 over 2. If I bring this one 2 up, it will be 2 over 5. But there's 4 there. That 2 will multiply 4, making 8 over 5. S to the power 5 over 2 plus this half, it will be 2 over 1, which is just 2 s to the power half. And we know that s to the power half simply means square root of s plus c. So that is the answer. So we have 2 square root of s, which is exactly what I gave here. Now, all these ones we have been dealing with, they are straightforward and direct integration. Now let us now consider techniques of integration. Techniques of integration. First one, we'll talk about integration by substitution. When do you normally apply integration by substitution? Integration by substitution is applicable when integral of product of two functions is given, such that the dimension of one of them gives the other one. For instance, let's consider this. You observe that when you differentiate sin s, you get cos s. In that case, we normally apply integration by substitution. So that means when we are given product of two functions integral, such that if you differentiate one, you will get the other, then you apply integration by substitution. So how does this method work? We consider the following examples. Integration by substitution exists in different formats. The first format is this: when you are given f of s and g of s, that is product of two functions, such that if you differentiate one, you will get the other one. Then you apply integration by substitution. Now, we consider the following example. Integrate the following. The first one, integration of sin s cos s. How do we do this? So you only need to first say that the one that if you differentiate, you will get the other. You know, we have said if I differentiate sin s, I will get cos s. You will say that let u be that function of s, that if you differentiate, you will get the other. You will see that let u be that function. After you have done this, the next thing is you differentiate as you have suggested. You differentiate like this: du dx. Or let's write it like this: if you differentiate u, just say du. Now if I differentiate sin x, I will get cos x. I will put dx. That's the second step. The third step now is that you make ds, that is substitution. You make ds the sort formula. How do you do that? You only say that ds is equal to du over cos s. This one, it can still be du ds. If I differentiate, I will say du ds is equal to, if I differentiate sin s, I will get cos s. After that, I will make ds the formula. I will just need to swap, which will give me this. After you have done that, you now come back to this. Let's say I is the integration. I will not come back to this. Here you have said let u be sin s. This is the u. Now, cos s, there's nothing representing it. I will leave it as cos s. This dx. So you bring this ds there. ds is du over cos x. This will cancel this. So what we are going to have left is u du. Now, that means what we are left with is integration of u. Don't forget that this is u raised to power 1. When we integrate u raised to power 1, it will give me u raised to power 2 over 2 plus c. But what is our u? Our u is sin s. So we bring it back so that our answer is sin square s over 2 plus c. If I let's say we are given another one, integration of, let's say, cos square s sin s ds. You observe that if you differentiate sin s, you cannot get cos square s. It's not possible. But if you differentiate cos s, you can get sin s. Not cos square s. So if you differentiate cos, ordinary cos, forget about the power that is there. If you differentiate ordinary cos, you can get this ordinary sin s. But if I differentiate ordinary sin s, I cannot get cos square because it is cos square you have. So since if you can differentiate cos s, I can get sin s. I will say that let u be that function that if I differentiate, I will say that let u be cos s. The next thing is I will differentiate du dx. If I differentiate cos s, I always have minus sin s, which we have done before under differentiation. The next thing is you make the s the subject of formula. So how do you do that? Just swap it. It will just be ds equal to du over minus sin s. So we just swap it. You can see minus sin s comes under the u. So that our I will be our cos s is u. But I have cos square s here, so it will be u squared. Sin s has no representation, but ds has a representation, which is this, which is du over minus sin s. This cancels this. What we have left is the minus comes out, u square du. Our aim is now to integrate u square. This is 2. If you integrate it, it will be u cube over 3. Finally, I will need to bring back my u. My u is cos s. So it will now be cos cube s over 3. We write it as cos cube s plus c. Don't write it as cos s cube. It's wrong. It is cos cube s. Now let's assume that we have another one. I have integration of s squared into 2s cubed plus 1 raised to power 5 dx. Observe that if you differentiate this, if you differentiate s squared, there's no way you will get this raised to power 5. But if I differentiate 2s cubed, normally if I differentiate 2s cubed, what am I going to have? I'm going to have 6s squared. If I differentiate 1, I'm going to have 0. So that means if I differentiate these two functions, I will have 6s squared. So since s squared can come out, then I can apply integration by substitution. Now that one that I want to differentiate to get the other, I will say that let u be that function. I'll say that let u be that function. The next thing is I will find the u dx. That is, I will differentiate. If I differentiate, I will have 6s squared. After that, I will make this ds the same formula, just swap. So ds will now be du over 6s squared. Then my integration will now become s squared. It has no representation, but this one has representation to be u. We say let u be that. It will be u raised to power 5 because there's 5 here. The x has representation to be du over 6s squared. So from this list, that s squared, if you have done your work very well, the variable will cancel each other as we have been doing. that x square will cancel each other. This is over 6. Let me bring over 6 out. We are left with u raised to power 5 du. Now, let us now integrate u raised to power 5. It will just be u raised to power 6 over 6. But we have known what our u is. Our u is 2x cubed plus 1. So we are going to have 1 over 36, because 6 times 6 is 36. U raised to power 6, this is our u. So it will be, this is our u raised to power 6, you see, plus c. So that is the answer to the question. What was the question again? This is the question. That's the question. Let's say I have another one. I want to integrate sin s exponential cos s dx. Observe that if you differentiate sin s, it can never go and cancel, it can never go and cancel what is on top here. So the best thing is, if I integrate this one that is on top here, it will give me, if I integrate this sin s, this cos s, sin s will come out. I can write it as, since I can do that, so I can say let u be cos s. The next thing I will say du over ds. If I differentiate cos s, I will have minus sin s. The next thing is I will make this ds the subject of formula. I will just swap it. It will be du over minus sin s. So that my integration becomes sin s has no representation at all. Our cos is u times dx. dx took as representation over minus sin s. This cancels this. Let me bring the minus out. So we have minus exponential u du. But integration of exponential u is still exponential u. Here, we said integration of exponential s will still give us exponential s. So in that case, integration of exponential u will still be exponential u, c plus c. Sorry. But we have known what our u is. Our u is what? Cos s. So the final answer to that is exponential s, minus exponential cos s. Let's say we have another one. Let's assume that we have this 2s squared, 2s over s squared plus 1 dx. Observe that if you differentiate s squared, you are going to have 2x. If you differentiate s squared plus 1, you are going to have 2s. So in that case, I can say that let u be s squared plus 1. The next thing is I will differentiate. I will say du ds. If I differentiate s squared, I will have 2x. If I differentiate 1, I will have 0. So I don't need it again. So that we are going to have, okay, the last one, I will make ds the subject of formula. That will be 2 du over 2s. I will not come to this place. Our answer will now be 2s over s squared plus 1. Our s squared plus 1 is u times dx. Our dx is du over 2s. From this page, you see that 2s cancels 2s. So what are we going to have left? We are going to have 1 over u du. And if you recall, integration of 1 over x means ln x. Integration of 1 over x means ln x. So that if I integrate this, I will have ln u. And what's our u? This is our u, s squared plus 1. So that our answer is ln s squared plus 1 plus c. So that's our answer. And also, let's assume that we have integration of sin x over cos x dx. Observe that if you differentiate cos, you will get sine. Because if you differentiate sine, you get cos. But when it comes to differentiation like this, you have to share from the denominator, because it is only denominator that can cancel numerator. This numerator cannot go and cancel the denominator. So if I differentiate cos s, I will get sine out. So in that case, since I can do that, I will say that let u be that cos s. The next thing is I will differentiate du ds. If I differentiate this cos s, I will have minus sin s. The next thing is I will make the s the derivative formula, so that I will have du over minus sin s. Finally, our answer becomes sin s over cos s. Our cos s is u, it has representation, times dx. This is our dx here. Du over minus sin s. Adding being we have made our u to be cos s, it won't cancel, as this one will cancel here. It won't cancel each other. So the best thing is we make our u from the denominator, so that I can cancel the one from the numerator. So this is minus, the minus is out. What we have left is 1 over u du. Let me bring the minus out. Our 1 over u, if we integrate 1 over u just like this, we have ln u plus c. But our u is what? Cos s. So our answer is ln cos s plus c. That means if I integrate sin s over cos s, I will have ln cos s plus c. Let's take another example. This is another example. We want to integrate integral 2s cos this dx. Remember, if you differentiate this 3 is 0. If you make 2s squared, it will give me 4x. So s can come out. This is x here. It can come out. In that case, I can apply integration by substitution. So the one that if you differentiate, you get the other. You just say it is not cos s that I will differentiate that I will get this. It is these two that if I differentiate, I will get x out. S will come out. In that case, I will say that let u be 2s squared plus 3. The next thing is I'll find du dx. That's the next step. If I differentiate this, I'll have 4x. This is 0. If I make the s the 0 formula, I'll have du over 4x. So that my integration will now become 2x. It has no representation. But this one has representation. We have said it is u, cos u. If I differentiate dx, this is our dx here, du over 4s. This s cancels x. Also 2 here 1, 2 here 2. So let me bring the over 2 out, 1 over 2, because it's at the denominator. What we have inside is cos u du. So I'm now left with cos u. So if I integrate cos u, I will get sin u plus c. So the table of table of integral is very important. This can pause it, write them out, and memorize them. They are very, very important. But what's our u? We have known our u to be this, so our answer is just 2s squared plus 3 plus c. So that's our answer. And the last but not the least, so if I consider, let's say I want to consider four s cubed into x to the power 4 plus 3 x to the power 7 dx. So I will leave this as an exercise. So you should try it yourself. But your final answer, if you try it, it will be x to the power 4 plus 3 x to the power 8 over 8 plus c. So follow all this, you should get an answer. You can practice these ones right from this place to this place. You can practice them. I'll put a final answer for you. Here, you let your u to be sin s. Here, let your u to be minus sin s. Here, let your u to be s cubed. Let your u to be cos x. Here, you make your u to be equal to this, s squared plus s. I told you, you make use of the denominator, and this one you let your u to be s cubed plus 4 plus 1. So that is case 1 for the integration by substitution. Let's consider another case. Our second case, if you have as plus b raised to power n, or function of as plus b, that is, if a function is having linear function inside it, this thing means linear function. That is, the power of the variable is 1. So you can still apply integration by part. Now let's take example. Let's say the first one, this will be example 2. Let's say the first one, I want to integrate 3s plus 5 raised to power 7. I want to integrate it. So when you have a linear function with power, we can apply integration by substitution. As usual, that function, that linear function, you say that let u be that linear function, which is 3s plus 5. The next thing, as usual, we find the u ds. If I differentiate this, I'll have 3. The next thing is I'll make the s the formula, which we have known that it will give us the u over 3. I will now come here. Since our u is this, our answer what we are going to have is just be u raised to power 7. Then our ds is du over 3. So let me bring this 1 over 3 out. All we have left is u raised to power 7 du. And we can integrate u raised to power 7, which will give me u raised to power 8 over 8. Finally, our answer is, we know 3 times 8 is 24. So this is 1 over 24. U raised to power, our u is 3s plus 5. This is our u. Then raised to power 8 plus c. So that is the answer. So it's very simple. So let's consider another example for better understanding. Let's now say we have 2 minus 3s raised to power 5 dx. As usual, let u be the linear function, 2 minus 3x. The next thing is du dx. If I differentiate it, I will have, if I differentiate 2, is 0. If I differentiate this one, I will have minus 3. The next thing is I'll make the x the subject of formula. That will be du over minus 3, as we have been doing. Then our integration will become, this one is our u. It will be u raised to power 5 dx. Dx is here. Our dx is du over minus 3. So let me bring the minus 3 out, but it's division. That is why I put 1 over 3. U raised to over 5 du. Now, if I now integrate u raised to power 5, I will have u raised to power 6 over 6 plus c. But we have known our u. 3 times 6 is 18. Then our u is this. So it will be 2 minus 3s raised to power 6 plus c. So that's our answer. So that is for this. If you consider this, if you have a function that is having linear function inside it, let's assume that you have sine 2x dx. This is a linear function. As usual, let u be that linear function, which is 2s. The u ds, if I differentiate 2s, I will have 2. If I make the s the same formula, I will have du over 2. So that my integration will become sine, we have said let this be u, sine u times dx. Our dx is du over 2. So I'll bring this half out. It will remain sine u inside du. Now we are left with integrating sine u, and if you integrate sine s, I will have minus cos s. In that case, if I integrate sine u, I will have minus cos u. So that my final answer is minus half cos, our u is 2s plus c. So that's the answer. That means if I integrate sine 2s, I will have minus half cos 2s. Another one, let's say I want to integrate this. Let's say I is equal to this. As this is a linear function, as usual, we say let u be that linear function. Then du dx is the next thing, which is 3. If I make the x desired formula, I will have du over 3 as usual. Then our integration will now become, it will be cos u, because everything here is u, times dx. So our dx is du over 3. So from that place, I should have 1 over 3 is out because it's division, cos u du. If I integrate cos u, I will have sin u plus c. So which is 1 over 3 sine, we have known our u to be this, sine 3s minus 5 plus c. So that is that about that. That is that about integration by substitution. We now move to another techniques of integration. One is integration by part. We have considered integration by substitution. Another technique is integration by part. That one is also product of two functions. I've given you two cases where we can apply integration by substitution, when we differentiate one and we get the other. But in this case, if you are given product of two functions, if you differentiate one and you did not get the other, that means you can't apply integration by substitution. So you have to look out for integration by parts. If integration by substitution cannot work, then by part can work. Let's take an example to explain this. This is a formula for integration by part. We say u dv is equal to uv minus v du. dv means differentiation of v, du means differentiation of u, and v means integration of v. So that means we need differentiation and integration under this condition. So let's say example 1. We want to integrate x sin x dx. If you differentiate sin x, you can't get cos s. If you differentiate s, you can't get sin s. If you differentiate sin s, you can't get x. So we have to apply integration by part. Now, see integration by part. The formula is u dv. That is, this is u. This one is dv. One is u and the other is dv. So you say let u be equal to x, let dv be equal to sin x. From this place, if you have done that, your aim is to do this du, because anytime we see u, we must get du. Anytime, so they must move together like this. U du, dv is given, we need v. What is the meaning of du? Du simply means differentiation of u. So if this d means differentiation, if I differentiate this x, I will have 1. Also, this dv means it has already been differentiated. I want to have v. So if I want to have v, v simply means integration. So that means I will integrate sin s, which I can do. It will give me minus cos x. Then our integration, which this integral s sin s ds, I will now use this formula. The formula is uv. This is our u. uv x into minus cos x minus integral v. What's our v? This is our v. Minus cos x du. What's our du? Our du is 1. So that's no signal. 1. So I'll put dx. Here we have minus s cos s. This minus times minus will become plus cos s dx. So we are just left with integrating this one alone. And if we integrate it, what are we going to have? It's just simple as ABC. Our answer will be equal to sin s plus c. So this is the answer. That means if we integrate s sin s, I will have this. So similarly, if you apply the same thing, if it is s cos s, so you are going to have s sin s, and that will now become, you have this. So you need to apply all this. So it's just an exercise for you. Now let's consider another example. We want to do this. S raised to power x dx. This, you say let u be x. The other one, because that is what we have, u dv. The other one is dv is equal to exponential s. As usual, I will find the u. If I find the u, I will have 1. If I differentiate this, I'll find the v from the v. V simply means integration. If I integrate this, I'll still get exponential s. So that my integral becomes, this is the formula, uv minus integral v du. uv, this is our u, uv x exponential s minus integral v du. This is our v exponential s. Du is 1, so it is ds. It has no significance. We are now left with integrating exponential s, which is easy. If I integrate exponential s, I will have exponential s, then plus c. So that is the answer to this integration. Another one, integration of x ln x. If I integrate it, so I will take 1 to be u and 1 to be dv. You see, anytime you want to make your u, most especially when you have this lane, you also always let your u to be this lane, because I can easily differentiate it. I cannot quickly integrate it. And you let your dv to be the second one, which is x or whatever that is there. From this place, I will need du. You know, if I differentiate ln x, if you can still remember, I will have 1 over x. Now it remains v. If I integrate, v means integration of s. And if I integrate, I will have, you know, this is s to the power 1. It will be s to the power 2 over 2. So that the integral becomes, so the formula again, okay, let me write it here so that we don't make, the formula is u dv is equal to uv minus integral v du. Now uv, let's say s ln x dx is equal to uv, this is our u times v, this times this. That will be s squared over 2 ln x minus integral v. This is our v times du. This is our du here, 1 over x dx. We put dx there always. So this, let me bring these 2 out, which is half. This cancels this. What we are going to have left is x dx. So that our answer is s squared over 2 ln x minus half. This is raised to power 1. If I integrate it, I will raised to power 2 over 2 plus c. Finally, our answer there is s over 2 ln s minus this one will be s over 2 or s squared over 4 plus c. So that's our final answer. Now, if we integrate, let's consider this. Let's say we want to integrate exponential s sin x dx. Now, as usual, let's say u is x, the v is sin x. Then the next thing is we need to find the u, which means differentiation. If I differentiate exponential s, I will have exponential s. This one, v, means integration of sin s, which is minus cos s. Then the integral, this integral will now become uv, that is minus exponential s cos s, minus integral v du. This is our v, minus cos x du is exponential s dx. So the integral becomes minus cos s, this will become plus exponential s cos s dx. You can see that we cannot integrate this thing. So I have to, I'll say still apply integration by parts. We will need to apply it once again because we can't integrate this. It is not easy for me to integrate this thing because it's still coming to something of this nature. I'll still apply it. In fact, we can apply it up to 4 times before we can get an answer. So when we still apply it, follow the same procedure. U is this exponential s, and the v is this cos s. If I differentiate, I'll still get exponential s. V means I should integrate this. If I integrate cos s, I will have sin x. If I integrate cos s, I will have sin x. Then my answer there, the I will become what we have here, minus exponential s cos x plus, now this is what we want to do. So we use the formula uv minus integral v du. Uv, there's nothing else. Uv, that is es sin s minus integral v du. This is our v du. That is exponential s sin s dx. Then that will give me I is equal to minus exponential s cos s plus exponential s sin s minus es sin s dx. You now agree with me that this thing is just like the question given to us. Is the question. This is the question. We have come back to the question given to us. This is it. We have come back to it. And we have labeled that question as I. So the question, that is why we are writing it as I here. So let me still write it as I equal to, let me write this plus first, exponential s. If I bracket, if I factorize, if I remove it, it will remain sin s. If I remove it, it will remain minus cos x. Now that is that about that. But for this one, is our integration, the integration we are finding. So we have written it as I. So it will still be minus I, because that is what we are using, and we have represented it by I. So, and this is I as well. So let's bring this I to the other side. So it will be I. When this minus I comes here, it will become plus I equal to exponential s into sin s minus cos s. I plus I will give me 2i equal to exponential s into sin s minus cos s. If you make I the square formula, you are going to have exponential s over 2 into sin s minus cos s. So what we are saying is that this is our I. Integration of sin s dx is equal to exponential s over 2 into sin s minus cos s plus c. So that's the answer to that integration. So you can similarly practice this exponential s cos s. What will it give us? Your final answer should give you exponential s over 2 into cos s plus sin s. So this is what it should give you.